Somewhere like New York, for instance, what we see there is that the AMOC pulls water away from the east coast. The sea level would be much, much higher around that east coast, and we could have really damaging flooding around the coasts of North America without the AMOC.
Mother Nature, she is looking out for all of us.
That's got to be one of my favourite movies. Ask any meteorologist. Twister and The Day After Tomorrow, these kind of weather disaster movies. The science behind that isn't really what climate scientists are expecting.
Sarah Keith Lucas, our favorite weather presenter. Hello.
Hello, thanks for having me, William.
We have a question for you. Hopefully it's not too hard. It's about the Atlantic Meridional Overturning Circulation, or AMOC. We've been seeing this phrase all over social media. What is it?
Yeah, it's a hot topic at the moment, the AMOC, isn't it? The Atlantic Meridional Overturning Circulation. So basically, it's a series of ocean currents in the Atlantic Ocean. They form part of the global ocean circulation system. Meridional means they're sort of aligned with the meridian, so north to south ocean current rather than east to west. And overturning means that it's not just north to south, but actually this ocean current dives deep down into the ocean, moves its way south, and then it upwells once again. So it's like a conveyor belt. And I think circulation reminds me a little bit of our arteries and our veins in our bodies. So a bit like that, these ocean currents deliver oxygen, nutrients and warmth to different parts of the ocean. So it's quite a complicated thing, but it's all to do with changes in both temperature and in saltiness of seawater, so salinity. If we take our starting point, for instance, imagine a bit of water in the tropical central Atlantic Ocean. It's warmed by the sun above, so it's warm surface water, and it's quite salty as well, because the sunshine evaporates water but leaves behind lots of salt crystals. So what happens to that warm, salty water? It moves its way northwards in the Atlantic. It reaches the colder Arctic Ocean, giving off heat to the atmosphere as it moves north. So that area of water then becomes colder, it's salty, heavy and dense, and it sinks down deep near the Arctic Ocean. It hits the seafloor and then it returns its way south, and eventually in the southern Atlantic, that area of dense cold water will upwell once again towards the surface, and we get this conveyor belt delivering heat and nutrients around the ocean.
Okay, so let me just make sure I get this straight. Warm water in the tropics, It's flowing north, it's cooling off, letting off steam perhaps, reaches the Arctic, gets cold and dense, falls under the water.
Yeah.
That current goes, I guess, westward and south?
Yeah, absolutely.
And then the cycle starts again eventually.
Yeah, so it's not quite that simple. It's not just one conveyor belt. It's actually a bit like our veins and arteries, lots of little currents, but that's the basic kind of overview of the flow that's happening within the Atlantic Ocean.
Okay, now what's the point of it? Nature, does it have a plan in doing this?
Yeah, it does. The Earth always has a plan. And actually, the globe is trying to always reach equilibrium. So the areas that are hot, that wants to flow towards colder conditions. The colder conditions want to flow towards hotter conditions. So the Earth is trying to keep a balance all the time. And that's why we see that heat given off into the atmosphere as it's trying to cool down those warm surface waters. And it really controls a lot of weather and climate around the world as well.
So are there any specific examples of countries that'd be impacted by the movement of these currents?
Yeah, absolutely. So the AMOC influences all sorts of things around the world. Well, firstly, of course, marine life and the ecosystems in the ocean. So that warm, nutrient-rich, oxygen-rich water is pushing its way northwards. So fish and mammals and plankton all rely on it too. But in terms of the weather and the climate, places like the UK and northwest Europe, we would be much, much colder if we didn't have the warmth given off by that AMOC. It adds about 2 or 3 degrees to our climate. So although we are kind of in London, not too far off the same latitude as, say, Moscow, the temperature doesn't get as cold here, particularly during our winters. So it certainly has a moderating effect on the weather across the northwest of Europe, but also the other side of the Atlantic. So somewhere like New York, for instance, what we see there is that the AMOC pulls water away from the east coast of North America. The sea level would be much, much higher around that east coast, and we could have really damaging flooding around the coasts of North America without the AMOC, but also much further afield as well. So places like West Africa, even in India, where we see monsoon rainfalls, it's partly the AMOC delivering warm air to certain parts of the world that creates our whole climatic regions. So where we see rainforests, for instance, because of that heavy rain falling in those areas, if we didn't have the AMOC, they'd be in very different parts of the world.
Gosh, Mother Nature, she is looking out for all of us. And as part of that, we have these terms, jet stream, Gulf Stream.
Yeah.
How does that factor in?
Yes, people often get confused between the jet stream and the Gulf Stream, and I hear this all the time, but they're really different things. So let's start with the Gulf Stream, because that's more linked directly with AMOC, as we're talking about. And the Gulf Stream is the warm river of air that flows from the Caribbean and the southeast of the United States. It moves right across the North Atlantic towards the UK. So that's the current of the ocean current that keeps things relatively warm in places like London, in Portugal as well. Porto would be much, much colder without the Gulf Stream bringing that flow of warm air. And it pushes about 1,200 Olympic swimming pool size water every single second. So it's one of the world's strongest ocean currents is the Gulf Stream, really impacting our weather and climate. The jet stream, now that's something very different. So the jet stream happens in our atmosphere, and it's about 6 miles above our head. A fast-moving river of air is the jet stream. And that changes shape and speed quite regularly. And where we see differences in the jet stream, that's what dictates where we get low pressure and high pressure, and why our weather is so changeable, really, is what happens with the jet stream. They're linked, the jet stream and the Gulf Stream, but they're very different things.
And you mentioned how AMOC helps the Earth, achieve balance in some way.
Yeah.
Now, we've seen on social media that some scientists and researchers are concerned and that climate change might play a role in their concerns. What's going on here?
Well, it's really quite a new kind of part of climate science, the studying of the AMOC and how it's changing. And we've only been studying it for about the last 20 years with any kind of continuous direct observations. Now, it is being studied by climate scientists, and they've got lots of little buoys in the ocean, little sensors. They dive down regularly to get measurements of what's happening with the ocean currents, and then they resurface again as well. So it is being studied. And climate scientists do think that climate change is having some impact on the Atlantic meridional overturning circulation, but they don't know exactly to what extent, because there could be some natural fluctuations in this system as well. But the consensus from climate scientists is that it may be slowing down. It may be weakening a little bit, perhaps by as much as about 15% over the last 100 years or so. So the reason for that is that as our climate warms around the planet, more glaciers and ice sheets, that's fresh water, are melting. So particularly from places like Greenland, for instance, if the Greenland ice sheet melts, that pushes more fresh water into the surface ocean. And remember, AMOC is driven by saltiness and a change in temperature. So if there's a lot more fresh water in the surface of the ocean, that slows down the engine of dense salty water that drives the circulation of these ocean currents. So it may be that although globally, of course, our temperatures are rising really quickly, the circulation of heat is actually slowing down in the Atlantic Ocean.
It's so funny, you said boys, and it's an American-British thing, because we say buoy. So I thought of small children being dropped into the ocean.
Yeah, buoys or boys.
And one aspect of this that caught my eye was something scientists have found called a cold blob in the North Atlantic. That sounds almost like it's out of a horror film. What is it?
Yeah, the cold blob. It's been there for a while now. And actually, we call it a blob, but it is a huge area of the North Atlantic, kind of the size of Western Europe at times. So a very big area that is actually cooling down. And it's really bucking the trend from the rest of the world, because for much of the world, of course, our land area is warming up quickly with global climate change. The oceans are warming as well. But we've got this strange area in the North Atlantic, and climate scientists don't fully understand why that area is cooling, but it has been said that it's evidence that the AMOC is slowing down. So the AMOC delivers that warmer water towards the north, but if not as much warm water is getting pushed northwards, that's why we could well be seeing the colder conditions developing in the North Atlantic. And of course, we were talking about the Greenland ice sheet. That's colder, fresh water melting into the North Atlantic. And because it's not as salty as the rest of the ocean water, it tends to sit on the surface.
Now, I don't want to put forward a doomsday scenario, but let's say that AMOC weakens or maybe even collapses entirely. What would happen?
Okay, so before we go into the potential impacts of if AMOC collapsed completely, it should be noted that it's what we call a Hill event. So it would be high impact, low likelihood event. So climate scientists don't think that the AMOC is going to completely collapse during this century, but it's not without the realms of possibilities. So it is something that we need to be talking about, having a proper conversation about what would happen if AMOC was to collapse completely. And really the potential impacts could be widespread and catastrophic, really. A huge change in climate for places like Northwest Europe. We talked about the AMOC keeping them relatively warm. So we could see a much, much colder climate developing. Somewhere like London could see the same climate as Alaska, for instance. And of course, our infrastructure just isn't built to cope with that. So yes, some places could get colder despite the overall global warming. But further afield, it could really shift whole climatic zones, like, for instance, the monsoon rains in West Africa and in India as well. We rely very heavily on those rains at different times of year, but those rain belts could shift much further south if the AMOC was to collapse completely. So in terms of food security, that could be under threat if we didn't see rain in the right regions. And in terms of climate migration as well, we could see, people having to move on a huge scale because the entire climatic region has been affected and ecosystems could potentially collapse with that, change in where we see the rain and in huge changes in temperature as well.
Hearing you talk about that, I can't help but think about this movie from, I think, 2 decades ago. It's called The Day After Tomorrow, and there's this sudden climate change event, and basically we're plunged into a new ice age. Yeah. Now, in the movie, it happens pretty quickly. What time scale are we looking at for the scenarios you've outlined to actually happen?
So that's got to be one of my favourite movies. Ask any meteorologist. Twister and The Day After Tomorrow, these kind of weather disaster movies. So the science behind that isn't really what climate scientists are expecting, because in that movie, of course, the Northern Hemisphere was plunged into a new ice age really, really quickly and very dramatically as well. So we're not expecting that, but the science isn't completely, isn't too far off, because we could see colder conditions developing despite our global warming if we reach what's called a tipping point in climate change. Now, we don't know what that tipping point is, so we don't know how quickly things would happen. But usually, what happens in the ocean takes a lot longer than what happens in the atmosphere. So the atmosphere reacts much quicker to climate change compared to the oceans. So it's more likely that it would be a very slow and gradual transition, the oceans taking decades or perhaps even centuries to react to human-induced climate change.
And have there been discussions around what we can do, so we don't reach that tipping point?
I mean, there are lots of discussions, and it really sounds very simple, doesn't it? Humans need to stop putting fossil fuels into our atmosphere. We do that by stopping the use and our reliance on fossil fuels, but also stopping deforestation as well. So trees are just the best carbon sink that we can get anywhere in the world. So planting more trees and releasing less fossil fuels, it sounds simple. We know we need to do it, but of course it's a massive undertaking to change society, communities right around the world.
Well, that is all for today. Before we go, we just want to shout out to some of you who left comments on our YouTube video, How Dangerous is Extreme Heat? This is Emma K2N. She writes, I live in South Asia. This region experiences intense heat during summer, over 45 degrees Celsius, which is quite unbearable, but still tolerated by people.
It's like stepping inside an oven, isn't it? That kind of temperature, 45 Celsius. I mean, our bodies are only at around 36 Celsius, so anything above that feels uncomfortable. So yeah, 45 degrees. I mean, I'm not used to heat like that. It's pretty tricky to tolerate.
Me neither. And this comment comes from a Vietnamese viewer. It is Dang Bui E9P8Q. Global warming or extreme heat waves are becoming more and more common coming from our human activities. We should collectively take immediate action unless we want to experience future bad scenarios.
I would agree. I think they're becoming so much more common, aren't they? These extreme heat episodes Even in the UK, we've had extreme heat this summer, and some other parts of the world are experiencing it much, much worse. So yeah.
Oh, indeed. Dang bui kaman Rutland you. We appreciate you commenting, and thanks to all of you for watching this episode of What in the World from the BBC World Service. If you want to subscribe, why not hit subscribe right now on the BBC World Service YouTube channel? More than 2 million people have already done so. I'm William Lee Adams. She is Sarah Keith Lucas, and we'll see you later.